Hello all, I'm Yogesh Gupta. Today I'm going to present my project of Data 670 Data Analytics Capstone, which is credit card fraud identification using SAS Enterprise Miner. This is for UMGC's 2023 spring semester. The data analytics problem that I'm analyzing is credit card fraud detection using deep machine learning algorithm. Credit card fraud is an easy target and increased recently due to the more online transactions and so the risk. There is a requirement to use different ML techniques to analyze the fraudulent and non-fraudulent transactions and design model which can be used to transaction data collected from customer and use the future analysis. Here is some background that I would like to share. As per the Nelson report, over last 5 years, losses due to credit card is nearly 43 billion, and it is expected to reach 408.5 billion in next 10 years, which is a huge problem. So there is a need to build a predictive model which can help. After building, compare the models and identify the best model for solving our problem. That's the goal of this project. Uh, As part of this project, there are some indicators that we would like to see. Indicator one is a project task completion as per the initial project plan. One important KPI for this project would be the completion of the project itself. This could include milestones such as completion of data collection and cleaning, and development and testing of the fraud detection model, and the implementation of the solution in the production environment for 100% on target. This KPI helps to ensure that the project is progressing as planned and that all the necessary work is being done in timely manner. Indicator 2 is about outcome benefit, and it is divided into two parts. One part is accurately identify the fraud detection in the credit card transaction by using machine learning models. Another key KPI for this project would be the benefit of the outcome of the analysis. This could include metrics such as number of fraudulent transactions detected with the minimum accuracy between 90 to 99%, the dollar amount of fraudulent transaction prevented, and the number of false positive, which is legitimate transaction correctly flagged as fraudulent. This KPI helps to ensure that the analysis is providing meaningful insights and that the solution is effectively detecting fraud. The second part of this KPI is the model performance. This could include metrics such as accuracy, recall, precision, F1 square, and then area under the curve, accuracy, sensitivity, and specificity. This KPI helps to ensure that the model is performing well, and it could be used to evaluate the performance of different models during the development process and also to evaluate the model performance over time. This can include reducing the false positive rate with threshold value between 1 to 10%, and which will be going to check at the end of the project as well. The indicator 3, which is identifying the fraud in the credit card transaction to help the end customer avoid losing their money. This KPI for this project is most related to the benefit of the outcome related to the organization. This could include metrics such as decrease in outcome complaints related to fraud, the increase in customer satisfaction and trust, and the decrease in financial losses due to fraud. This KPI helps to ensure that the organization is realizing benefits from the work being done and that the solution is being addressing the problem of credit card fraud. Thresholds of this KPI depends on the specific goals and budget of the organization. Uh, Here's the data set that I will be using for the credit card fraud detection prediction. Uh, for the credit card fraud detection project, there are multiple datasets available on a different website. The dataset was collected and donated is going to use here is was donated by a machine learning group and ULB. The data was collected from a European credit card issuer in September 2013 and contains transactions made by credit card in 2 days where hundreds of frauds out of many transactions were detected. The data was anonymized and contains information such as time of transaction, amount, and anonymized features. The data was collected as part of the research project and was made publicly available for use in machine learning and data analysis project. The data was collected using automated data extraction method from transaction logs and database of the credit card issuer. Let's look at the data set itself. As seen in the snapshot, we have 492 frauds out of 284,807 transactions. The data set is highly unbalanced. The positive class, which is frauds, accounts for almost 0.172% of all the transactions. It contains only numeric inputs, variables such which are results of PCA transformation. Unfortunately, due to confidentiality issue, we cannot provide the original features and more background information about the data. So it is indicated as feature V1, V2, and V28, which are the principal component obtained with PCA. The only feature which have not been transformed with PCA time and amount. Feature time contains the second, which is elapsed between each transaction and the first transaction in the dataset. The feature amount is the transaction amount. This feature can be used, for example, dependent cost sensitive learning. Feature class is the responsible variable and it takes value between 1 in case of fraud and 0 otherwise. Here is a little snapshot of how the data looks, right? So if you look at it, the two unique value of target variable between 0 and 1, and 1 for fraudulent transaction and 0 for non-fraudulent transaction. And if you look at the right graph, which talks about the highly imbalanced, the data values is average ranging from positive and negative as a swing. So there's a lot of work was supposed to be done. So data analytic strategy that we use here is going to help me derive the future analysis. Data analysis strategy refers to overall approach or methodology used to analyze a given data set. It typically involves a series of steps that are followed in order to extract insights or knowledge from the data. There are several data analysis strategies that can be used, including exploratory data analysis, statistical analysis, machine learning, and data visualization. Each of these strategies has its own strengths, weaknesses, and it's appropriate for different types of data analysis problem. For this project, I'm going to use the machine learning strategy to build predictive model that can make predictions based on new data, and the data visualization strategy is used to communicate insights and finding from the data in a visual format. The expected outcome of the analysis will be linked to my KPIs of this project, which is determined based predictive model, which can help identify the fraudulent transaction with 90 to 99% accuracy, or maybe more. Building the metrics such as accuracy, recall, precision, FN score, accuracy, sensitivity, and specificity to ensure the selected models are performing as expected. I do not want to drain the slide here, but as you see, I will be using the best of SAS, EM, and tabular functionality to analyze the visualization and the credit card fraud detection problem. Let's look at now a few visualizations which created for the credit card fraud detection analysis project. First one is correlation visualization. A correlation matrix for the credit card fraud detection dataset provides the correlation coefficients between all pairs of variables in the dataset. This helps to identify any strong relationship between variable and can be used for feature selection and understanding the underlying structure of the data. Since SAS-EM was unable to provide the correlation matrix due to the data size, I used R to create the correlation matrix in which you see here. As seen in the figure here, amount has strong negative correlation between with the variable V1, V2, V3, and V5. Also strong positive correlation with the V6, V7, and V20. Similarly, variable time has strong negative correlation variables, which is V3, V11, V15, and V25. Also moderate positive correlation variable between V5, V12, V22. Whereas the target variable, which is class, which you see here, is primarily strong negative correlation with the variables such as V10, V12, V14, and V17, and also moderate positive correlation with V4 and 11. Insights from the visualization include that the amount spent is an important factor in the determined fraud. As the amount spent increases, the probability of fraud also increases. the feature V10, V12, V14, and V17, which shows a negative correlation with the fraud, may indicate that the presence of this feature decreases as the probability of fraud. Let's look at the second visualization. So this visualization is primarily the graph between time, amount, count of class, which can reveal important insight about the data. The time variable represents the time elapsed between each transaction and the first transaction in the dataset average amount. By plotting the time against the count of class, we can determine if there are any patterns or trends in fraudulent activity over time. For example, it is noticed that the fraud is more prevalent during certain times of the day or week is that at 41,000 or 11th hour and 93,000 or 25th hour from the start. It is seen that higher number of fraud transaction, which is 37 and 29 respectively, as marked in the left graph in the blue. Rest of the time, it is low to moderate number of fraud traces observed. For example, you may notice that fraud tends to occur more frequently for high value transaction during certain times of the day. This can also be seen in figure at right for amount 121.78 and 87.32, which are above average amount, seen more fraud cases than other or below average transaction. The third example here is of a tree map. View chart can provide a visual representation of time and duration of each transaction as well as the transaction amount and class. By analyzing the tree view chart between credit card and count, time amount, and count of class, we can gain insight such as number one, which is fraudulent activity over time. If you see a cluster of fraudulent transaction during a certain time period, is that at 77,440 time, there are two distinct class and maximum amount is 5,668. With such information, it can be investigated whether there was a data breach or other security issue during that time. Second, fraudulent transaction by amount. Here you can see the maximum amount is 25,691 when the time is 164,560. If there are many fraudulent transactions for high value amount, there could be need to adjust fraud detection strategy accordingly. And the third one, duration of transaction. If a transaction has an unusually long duration compared to other transactions of the same type, it may be a sign of fraud. Another visualization generated, which was here, you can see on the slide, one is class for cluster plot diagram, which is seen at the left, and the right, we have a decision tree diagram. Uh, in the credit card fraud detection analysis, a cluster plot between time and count of class can help identify patterns and cluster of fraudulent activity over time. By analyzing the cluster plot, the observation which can be identified are number one, time periods with the high fraud activity. If the cluster plot shows cluster of fraudulent transaction during certain time period, we will be able to identify windows of time when the fraud is more likely to occur. This information can be used to adjust fraud detection strategies such as increasing monitoring or alert threshold during high risk period. For example, it can be seen from the above diagram that a cluster 3 with the large number of fraudulent cases are seen between 40K and 90K time period. Similarly, second point, which is similar pattern of fraudulent transactions. If a cluster plot shows similar pattern of fraudulent transaction occurring at the different time, we can identify specific fraud tactics or methods that are being used. This information can use to improve fraud detection algorithms and refine fraud prevention strategies. For example, as you see here, there are three distinct clusters based on the number of time the class of transaction occur. So cluster 1 is between 0 to 5, cluster 2 is between 5 and 15, and then cluster 3 is 29 and above. And the third point which helps us identify is the difference between fraudulent and non-fraudulent transaction. The cluster plot can also help us identify difference between fraudulent and non-fraudulent transaction in terms of their time pattern. For example, if fraudulent transaction trend to occur at different time of the day or weak or compared to non-fraudulent transaction, this information can be used to provide fraud detection models. The second plot, which is decision tree model for visualization. As a visualization technique, a decision tree provides an intuitive and interpretable way to represent the decision-making process used by the model. The tree structure can be visualized graphically, with each internal nodes represented by a branching point and each leaf node represented by a terminal point. The branching points correspond to the test on the feature, while the terminal point corresponds to the class labels or probability distribution. I used R programming here to create this visualization because it was a bit difficult in the SAS enterprise model. In the same regards, it is seen in the above diagram uh, that when like variable 17 value is greater than or equal to negative 2.8 and variable 14 is not greater than or equal to negative 8.1, there is a possibility that the transaction is a fraudulent transaction. Also, when variable 17 value is not greater than or equal to negative 2.8 and variable 12 is greater than or equal to negative 2.2, then the possibility is that the transaction is non-fraudulent transaction, which is uh, which is shared here. Similarly, if path is followed to a shaded box, we see that V16 is not greater than equal to 2.8 and transaction is a fraudulent transaction, and when V27 is greater than 1.1, transaction is non-fraudulent transaction. It can be seen in the graph. Now let's look at a few predictive models which were generated for the data analysis. The first one is being a logistic regression. Logistic regression is a commonly used algorithm in credit card fraud detection. It is a type of supervised learning algorithm that uses a logistic function to model the probability of binary response variable in case where the transaction is fraudulent or not. The model estimates the coefficient of the independent variable to predict the likelihood of fraudulent transaction, one of the transaction data provided. The first step in the developing a logistic regression model for credit card fraud detection is prepare the data. This includes cleaning and processing of the data, handling missing values, then scaling the features and compare the scale. Then the model was trained using the subset of data. The performance of the model is evaluated using metrics such as accuracy, precision, recall, and F1 square. The same is shown in the table here. In interpreting the results of logistic regression model, performance metrics accuracy is 100%, sensitivity is 81%, precision is 86%, and specificity is 100%, and the F1 score is 84% for validation models. The insights gained from the logistic regression model for credit card fraud detection can be used to improve the fraud detection and prevent strategies. The second model created here you can see is a decision tree model. The decision tree model is popular machine learning algorithm used for classification and regression problems. One of the advantage of decision tree model is that they are easy to interpret and visualize. The tree structure allows analysis to easily see the decision rules and importance of each feature and determine the classification of credit card fraud. Additionally, decision tree model can handle both categorical and non-continuous variable as well. The SAS enterprise model, which is decision tree diagram is shown here. The dataset was prepared, cleaned, and transformed using replacement data partition function. Then decision tool model was used to predict the outcome. The algorithm works by recursively splitting the data into subset based on feature that best separate the positive and negative class of credit card fraud. At each node of the tree, a decision rule is applied to determine which subset of follow until final decision is made. It was shared earlier in the visualization section as well. As seen in the result, with the logistic regression model, in the performance metric, accuracy is 100%, sensitivity is 80, precision is 94, and specificity is 100% with F1 score it being 86% for validation model. The leaf statistic graph, which is shown here, shows the distribution of class labels or probability for each leaf mode. This graph can be used to visualization the decision boundaries created by the decision tree. The third model which was generated was a neural network, which is ANN. Neural networks are widely used for credit card fraud detection. A neural network is machine learning algorithm inspired by a function of the human brain. It is made up of interconnection nodes that perform computation on the data fed into the network. And the neural network model for credit card fraud detection is designed to learn from historical transaction data and identify the patterns and that are indicative of fraudulent activity. And it can be fed real-time data to the further improve the predictability. Once the data is prepared, the neural network is designed and trained using the trained data for deep neural network. As seen in the node property, the misclassification was the mode criteria was selected for the analysis. The ANN has many layers of interconnection connected node. The input layer of the model is connected to the output layer through the several hidden layers. Each layer uses a set of weight, bias, and transform the data fed into it. During the training, the weight and the bias are adjusted using the optimization algorithm to minimize the error between the model prediction and the natural outcome. A score ranking overlay chart seen in the above figure is a graphical tool that displays the relative importance of each input variable in predictive the target variable. It is often used in feature selection, which is process of identifying the most relevant input variable for building a predictive model as seen in the graph. A cumulative lift depth is very much aligned for the both train and validate dataset. The model performance based on the data collected outcome of the calculation is shown here as well, which shows the for neural network model performance metrics accuracy is 100%, sensitivity is 80%, precision is 83%, and specificity is 100% with F1 score being 81% for validation model. The insights from the neural network model can provide valuable information for credit card companies to improve their fraud detection systems. The model can identify which feature are most important in decision fraud or allowing the company to focus on the features in their fraud prevention analysis strategies. The model can also identify trends in fraudulent activity such as the time of day or specific amount range of fraudulent transaction, which can be used to implement the target fraud measures. Uh, to identify the champion model, I created additional two predictive models like HP High Performance SVM and HP Forest, and they along with the our logistic regression, decision tree, and neural network model. The diagram and the associated results are shared here in the subsequent slides. In the model comparison, a sensitivity versus specificity graph helps to evaluate the performance of different models by comparing their ability to correctly identify positive and negative instances. Sensitivity is the ability of model to correctly identify the positive instances, while specificity is the ability of the model to correct identify the negative instance. A sensitivity versus specificity graph plots the sensitivity on the y-axis and the specificity on x-axis. Each point at the target presents performance of the particular model. And you can see this in three model plotted for specificity against the sensitivity, where you can see HP Forest is showing the highest or close to 1 sensitivity. Similarly, as seen in the classification chart, which is visual representation of the classification model performance, amongst the all, the HP Forest model is good at recognizing the true positive and true negative, making it good model so far. The table shown above is a comparison of different machine learning model for credit card fraud detection, including decision tree, HPSVM, neural network, regression, and HP Forest. Each row represents a different model with separate column for the data role, train or validate. Target variable for false negative, false positive, true positive, and performance metrics such as accuracy, sensitivity, precision, specificity, and F1 score. Based on the table, the best performing model in terms of accuracy is HP Forest, achieving 100% accuracy in both training and validation data roles. The HP SVM model also achieved 100% accuracy in both data roles, but did not detect any false negative or true positive. In terms of sensitivity, the decision tree and neural network model perform the best, achieving 76% and 79% sensitivity respectively. The precision of the models range from 83% to 97%, with the HP Forest achieving the highest precision. The specificity of the models range from 100% to 94%, with the decision tree achieving the highest specificity score. Another insight from this comparison is that the performance of the model very depends on the data role, which is train or validate. For example, the neural network model achieve higher sensitivity and precision in the validation data role compared to the training data role, which is 80 versus 79. This suggests that the model may have overfit to the validation data and may not generalize well to a new data. Therefore, it may be important to evaluate the performance of the model on separate validation test data, and test data set to ensure that the model can generalize well known with the known data. Let's do the review of the finding results. The comparison table for event classification of the 5 model is shown in the table here. From the given data, it is evident that the HPSVM model, which is HPSVM 15, has the highest number of false negative in both training and validation set, while the model has 0 false positive in both set. This indicates that the HPSVM model has better accuracy in predicting the positive target class than other models. The neural network, which is neural 4, has almost similar number of true positive and false negative as a regression model, which is reg 4, but it has a higher number of false positive. This suggests that the regression model is better at correctly predicting positive target class instances than the neural network model, but it still has room for improvement in reducing false negative. The regression model, whereas which is Reg 4, has a lower number of false negative than both the decision tree and neural network models in the training set, but a higher number of true positive in the validation set. This indicates that regression model may have overfit the validation data, leading to the poor performance of the new unseen data. Overall, these findings highlight the importance of evaluating model performance on both training and validation sets to ensure that the model generalizes well to new data. The HP Forest model stands out as having the best performance with 0 train misclassification rate, ROC index as 1 for training set with the lowest valid as well as test misclassification rate, while the other models have varying levels of performance in preceding positive target class instances. Uh, Credit card fraud is a major issue in the financial industry, and it is essential to develop advanced methods to detect and prevent it. One recommendation for future analysis, it is important to consider the potential use of blockchain technology in the credit card fraud detection. Blockchain technology provides a secure, decentralized ledger that can be used to store transaction data. This technology can be used to create a tamper-proof record of transaction, which can be used to detect prevent fraudulent activities. By using blockchain technology, banks can create a more secure and transparent system that is less susceptible to fraud. Another potential area for future analysis is the use of natural language processing, which is NLP technique to analyze customer complaints and feedback related to credit card fraud. By analyzing customer complaints, banks can identify patterns and trends that may indicate potential fraud activities. By understanding the customer concern related to fraud, with the help of this sentiment analysis, they can develop more effective strategies to prevent and detect fraudulent activity. The another potential area for future analysis is the use of explainable artificial intelligence, which is XAI technique in credit card fraud detection, which the XAI technique can be used to create models that are more transparent and understandable, allowing for better decision making and accountability. Same time can help reduce customer concern related to privacy and security. Finally, it is essential to consider the use of real-time analytics coupled with the use of biometric authentication in credit card fraud detection. In the real-time analytics, which can be used to help banks identify fraudulent activity as they happen, and allowing for immediate action to prevent further losses. Similarly, biometric authentication, such as fingerprint and facial recognition, can provide more secure and accurate way of verifying customer identities. Uh, during the project, I think there are many lessons learned. Few are listed here, which I'll share with you. So, number one was business problem. The importance of understanding the business problem and goals of the project in order to design an effective solution. Same time, the importance of understanding the distinct type of fraud and patterns and characteristics associated with the each type. So the second is data set and data quality. I think the importance of obtaining the high quality data, relevant data, and also making sure data is clean, processed in order to prepare for the analysis is important as well. The challenge and the consideration of working with large complex data set is another lesson that is learned, because that was definitely witnessed here. And identify the relationship between various variables, that was another learning as well. The third is definitely model development. There are various models that were developed, but robust and flexible fraud detection model which can adapt and changing pattern and characteristics is key, and understand how the different variables will impact the cause and help provide the inside analysis. And finally, definitely the lessons learned against the visualization, the right data analytics technique, and also importance of the data analysis technique is to visualize them is important, because sometime I had to use SAS, enterprise miner, and sometime R, depending upon where it performed well and gave me the output. What next? I think from here, I feel the few things that can be done. Number one, implementing the fraud prevention measures, right? If the analysis identifies specific pattern or behavior that indicates fraud, the organization may want to implement a fraud prevent measure, such as monitoring transaction more closely, increasing authentication measure, or implementing machine learning model to detect fraud in real time. The second is updating fraud policies based on the findings of the analysis for organization. They may need to update its fraud policies to better protect against future fraudulent activity. This could involve maybe revising their internal policies, such as employee training or security protocol, working with external partners and vendor, all the new technologies that will be involved as well. The third will be sharing the finding once it is implemented, right? So result of the analysis can be shared with other departments within the organization, such as risk management or compliance, and improve the understanding of fraud risk and facilitate better decision making. And the next step could be the review the data collection practices. The analysis may reveal the gaps in the data collection process, and such as missing or incomplete data that could hinder fraud detection. In such case, the organization may need to review its data collecting practice and make necessary changes to improve the data quality. And then finally, monitoring and evaluating after implementing the fraud prevention measure. It's important to monitor and evaluate their effectiveness regularly. That can involve the regular reviewing transaction data to identify any new pattern or suspicious activity, adjusting the fraud prevent accordingly. Okay, so these are the next steps which I see could be enable us to take this forward into the uh, data identification process. Here are some references that I use for my project. Appreciate your time. Happy to take if you have any further question. Thank you. Have a nice day.